Okay, this is the AP review, starting with number 1 on the little paper that I gave you today. The diagram shown here represents a block suspended from a spring. The spring is stretched 0.2 meters. If the spring constant is 200 newtons per meter, what is the weight of the block? Well, it's important to note this is no energy in this equation. You're just trying to figure out what the weight of the block is. So you draw a free body diagram. It's got spring force up, force of gravity down. Force of gravity, remember, is the same thing as weight. If it's safe to assume it's not moving because it says it is suspended. So that means the spring force has to equal the force of gravity. And the spring force is Kx equals the force of gravity. And K is 200 times 0.2 equals the force of gravity. And that would give you 40 newtons equals the weight. Number 2, the important thing to note here is it starts off, equilibrium is at 0.1 meters. So then at point A, we're at 0.15 meters, and at point B, we're at 0.2 meters. So what that means is x on this one is equal to 0.05, and x on this one is equal to 0.1. So B, the x for B, the x for B is equal to twice the x for A. And since we're looking at what is its potential energy is 1/2 kx squared. So since you're doubling the x, you're quadrupling the potential energy because of this x squared term. Number 3, which graph best represents the relationship between kinetic energy and velocity? So the important thing here is kinetic energy equals 1/2 mv squared, and since it's a squared v, k versus v will be exponential. It's the same thing with number 4. You're looking at the potential energy of the spring, and that's 1/2 kx squared. So if you've got potential energy on the side and x on the bottom, it will be a curved relationship. Note, if it's gravitational potential energy, though, versus height, that would be a linear relationship because that is mgh, and the h is not squared. Number 5. The diagram shown represents a frictionless track. A 10 kilogram block starts from rest at point A and slides along the track. As the block moves from point A to point B, the total gravitational potential energy change into kinetic energy is approximately. So the thing that you need to recognize is if it's sliding down, then all of the potential energy at the top is going to be converted to kinetic energy at the bottom. Okay? So the way you calculate the potential energy at the top is mgh, and you're just looking for that kinetic energy at the bottom. So we get 10 times 5 equals k, which is 500. Alright, so 500 joules equals k. Number 6, a 20 Newton block is at rest at the bottom of a frictionless incline as shown in the diagram. How much work must be done against gravity to move the block up the incline? So we're doing work against gravity. So the question you have to ask yourself is, which direction does gravity act? So gravity only acts up or down, right? Gravity can only act in the up-down direction, the y direction, and so the displacement is the displacement in that direction, which is the 3 meters. So the work that you have to do to resist gravity is the force of gravity times 3 meters. It's a 20 Newton block, so 20 times 3 equals 60 newtons. Number 7. The diagram shows a 1,000 Newton crate, so the weight is 1,000 newtons, and we're trying to lift it at a constant speed. So since it's got a constant speed, we know the change in kinetic energy will be equal to 0, and we're lifting it 1.5 meters in 5 seconds. 1.5 meters in 5 seconds. So we're looking for power. Power is work divided by time. So power equals work divided by time, but we need work. Work is equal to force times distance. So we know work is equal to 1,000 times 1.5, which gives us 1,500 joules. And then power is equal to 1,500 joules divided by 5 seconds, which gives us 300 watts, or 3 times 10 to the second watts. Number 8, which action would require no work to be done on an object? The answer to that one is D, because you're not actually moving the object any. There's no motion. There's no change in distance. Okay? On to the book problems that I assigned you. These are just some practice, extra practice. So, number 25, the answer is, the reason there's more, it's different, is because there are different mu's. Alright, so you have different mu's. For the sandpaper, the mu is going to be much greater than the mu for the other one. And so since you have those different mu's, you have a different force of friction, you have a different force of friction, you have a different work. Okay? 26, what happens to that excess energy? It doesn't just dissipate, it transforms into heat or thermal energy. Number 29, when does a pendulum have the highest gravitational potential energy, and when does it have the highest kinetic energy? For a pendulum, at the highest point here, this is when it has max potential energy, and here is where it has max kinetic energy. Okay? Number 44. Says if you can only apply a 200 Newton force, but you need to make a 20 kilogram wagon of mulch travel at 10 meters per second, how far do you have to push the wagon before it reaches a speed of 10 meters per second if you start from rest? Okay, so we can assume no friction, so the work being done is changing the energy. The energy we're changing is the kinetic energy, and it starts with 0 kinetic energy. So really, the work we're doing is going to have to equal that final kinetic energy. So, the force that we can apply is 200 newtons. We're looking for the distance, and we've got to have, we've got to be going, 10 meters per second. So, 1/2 mv squared, 1/2 times 20 times 10 squared. So we get 2,000 times 1/2 is 1,000 equals 200 newtons times d, divided by 200, and we get 5 meters. Okay, so that's number 44. Number 50. Number 50 says, Nina, whose mass is 60 kilograms, is traveling on a bike at 15 meters per second at the top of a 3-meter hill. Nina continues down the hill without pedaling. Assume friction is negligible. What energy transformation is occurring as she travels down the hill? So for A, the answer is potential energy to kinetic energy. That's the transformation that's happening. How fast is she going when she reaches the bottom of the hill? So for B, we have E1 equals E2. Now at the top of the hill, she's got kinetic energy and potential energy. And then at the bottom of the hill, she just has kinetic energy. So 1/2 times m times 15 squared plus m times 10 times 3 equals 1/2 times m times v squared, the v that you're looking for. Cancel out the m's. We're left with 112.5 plus 30 equals 1/2 times v squared. If you solve for v, you get 16.9 meters per second. Number 54, a 15 kilogram ball is thrown straight up at 20 meters per second. What is the maximum height? So at the bottom it has kinetic energy, and that's equal to the potential energy at the top. So 1/2 times mv squared equals mgh. M's cancel, and you're left with 1/2 v squared divided by 10 equals h. So we plug in 15, and we get H is equal to 11.25 meters. Number 56. Dennis drops a quarter off a skyscraper. The quarter hits the ground at 25 meters per second. How many floors above the ground is Dennis? So what we have to do is figure out how far it fell. So we go 1/2 mv squared. The kinetic energy at the bottom is equal to mgh, the potential energy at the top. Don't really care about the mass of the quarter. So 1/2 times 25 squared is equal to GH. G is 10, remember, so 10H. So divide both sides by 10. So 1/2 times 25 squared divided by 10 is equal to H. Okay, so if you do that, you should get, let's see, 31.25. Okay, 31.25 meters is H. But you notice they want it in floors, so remember that the floors are 3 meters apart, so divide by 3 and you get 10 floors. Okay, so this is the review to help you with these problems. If you have any other questions, please let me know. I'll be happy to assist you. And I think that's it.